Hello, my name is Ike McKinley, and this is NOS 220, Linux System Administration. In this video, we'll be taking a look at the Linux hardware infrastructure and how to use it. We'll start by exploring the Linux hardware abstraction layer, known as HAL, and the udev system that is used to connect, populate the hardware infrastructure. We will then go on to examine the sysfs file system. And we will also take a look at the /dev file system, where older device drivers place device files. Finally, we'll examine the Linux kernel device drivers themselves, and we'll take a look at some of the tools that we can use to manipulate them. The basis of the Linux hardware system is the hardware abstraction layer. All hardware in Linux is represented in HAL, and its driver dbus, which handles all hardware events. The HAL system is an interface between Linux and the kernel drivers that actually control the various hardware systems. In addition, HAL interacts with the udev system, which is a series of rules controlling which actions need to be taken when various hardware is detected. Generally speaking, the administrator will almost never interact directly with HAL, but occasionally complicated hardware configuration, such as configuring wireless network devices as, say, a host access point, will require accessing the HAL system directly. The relevant files are usually located in etc/dbus-1 or /etc/event.d. Modifying these files should only be undertaken as a last resort, but it can be useful to know where to look to find out what's going on. The usual method to modify Linux hardware behavior is via the udev rules. These rules are located in /etc/udev/rules.d, and they are triggered whenever a hardware of a certain type is detected. The rules are numbered so that they check for hardware in a certain order. For instance, the 70-persistent-net rules file checks for network devices, and the detected devices are added to the file. It comes after several of the other rules that start with 10, 20, 30, 40, or 50. So when a network device is detected, it is named according to the rule, and the appropriate kernel driver is selected, and an entry is made into the sysfs file system. The sysfs file system is the primary method in modern Linux systems, whereby the system keeps track of installed hardware, and it is usually located in the /sys directory. Unlike the older /dev file system, sysfs organizes hardware devices based on the type of device, how it's connected to the CPU, and several other criteria. Because of the complexity of the system, a given device will almost always have multiple sysfs entries. For example, a disk drive, which is a block device, will be represented under /sys/block directory. However, as it is also connected via the PCI bus, an entry would also exist in the /sys/bus/PCI directory. Also, sysfs contains a great deal of information about the device, including descriptions, the device driver, and what resources the device is using. The other directory that contains device information is the /dev directory. Unlike sysfs, the entries in dev tend to be fairly flat and rarely contain more than a simple file system node that points to the device in question. The dev file system, however, is still a useful place to look, as many device drivers still place a link to the device there. Thus, the first SATA hard drive would be represented by the /dev/SDA file, and the first partition on that drive would be represented by the /dev/SDA1 file. All of the elements that we've discussed so far deal with how devices are represented to the operating system. What about how the devices themselves are managed and controlled? Like most operating systems, Linux does this through the use of device drivers. Unlike Windows, almost all Linux device drivers are included with any Linux installation. They are, in fact, part of the Linux kernel and called modules. Most of the time, modules are automatically loaded by udev or HAL, but sometimes modules need to be loaded or reloaded manually, or even added to the kernel from third-party sources. In these cases, the administrator should be familiar with the 4 module commands: lsmod, insmod, rmmod, and mod probe. The lsmod command lists all of the modules currently in memory and which modules that they depend on. For instance, a USB storage driver needs a USB core module loaded. The insmod and rmmod commands insert and remove modules from memory. Finally, the mod probe command does both of these. The removal is accomplished with mod probe -r, but automatically loads and removes dependent modules. So, today we've had a quick look at the Linux hardware infrastructure and how it functions. We've examined the HAL and udev hardware file systems, the kernel module for device drivers, and some of the commands that hold all of these together. Next time, we'll be looking into the most neglected of administrator responsibilities: backup and recovery.